Hello and welcome to a recorded tutorial. Thank you so much. I'm very grateful that I'm able to do this and go to work tomorrow. We have a meeting with the externals. This tutorial will cover firstly our fishing worksheet. So I'd like for you to get your field data, your worksheet that you've written in together, and then get a copy from Moodle to work on. Just to start with where our site was. So this little peg here explains that Coal Hill Lane, Nangaroo River Coal Hill Lane is where we are. This is Glenbervie Forest above it, and Glenbervie Forest is the headwaters for that stream or river. And it flows through the headwaters and comes down to these lifestyle blocks and fish, sheep and beef farms and some dairy, and there were horses there too. Then it flows down further through more lifestyle blocks with sheep on them and horses on them, and then it flows into this Whangaulu Bay. And I think Kahi was telling me in the drive down that this sand spit here uh, is very culturally important for Ngati Wai is the tribe that that spirits leave from this sand spit, so it's culturally very important. And in early 1900s, this area Kiripaka, it had, you can see in the slide there, it had coal mining occurring from like early 1900s till 1920s, and this river must have been used for transportation uh, of that coal and people. What this shows you is in the context of where your site is, it shows you that the headwaters are in forests, and then the coast is pretty close. Like it's not, the coast is pretty close. It's, if I was a fish, if I were a poor climbing fish, it would be easy for me to come up till here. The chances of having major waterfalls or big culverts is low in this area. It's lightly populated, so this is the only road that goes through it, and it's along the river. So having major waterfalls, cascades, or culverts or weirs that would cause fish barrier are less in this area. So it would be easy for fish to come up here, which would affect populations, numbers, and abundances, which you could use to discuss in your answers. Then, nutrient-wise, there are some farms in the area, but most of the stream in the headwaters is in forests. That's something to note. But around where our site was, a few, I think if we look at the kilometers, like it's 2-3 kilometers is passing through farming area. So that's something to keep in mind. And if you ever work for a consultancy or the regional council and you're planning a survey, look at the site from this zoomed out version so you understand how far it is, where its headwaters are. If you've got other layers for fish barrier or for land use, put them on and understand what and how much effect it might have on nutrients and such. Then maybe pause the video here, download your worksheet from Moodle because question 8 was changed and I've changed it in the uploaded version. Keep your field sheet with you, keep your actual worksheet that I had given you. Maybe you've written answers in there, keep that with you, and then maybe do this while, go through this tutorial while you're doing your worksheet. From the last worksheet that I marked, I want you to remember units, please. So wherever in the whole worksheet, a constant reminder is use units. Make sure that what you are explaining here, anybody in the world can understand what conductivity is. They can compare it with their own units. So Site name and location is important. This was the site we went to. You can go to any NRC website or land, air, water, land and water and atmosphere website, LAWA website to check the site. It's there. It's got water quality data. It's got fishing data. It's got macroinvertebrate data. There's reports out there. So maybe while you've paused, have a little search, look for those reports, try and see what this site's about. Is it a good site? Does it have high water quality bands? Try and look and understand. Then the date of when you did your survey, total shock time, start and finishing times are important, and clarity, because if it was low clarity, we wouldn't be using electric fishing that day. Then you know how important conductivity and dissolved oxygen are for when you're planning a fish survey. So make sure you have those noted down and that you have units. Then weather conditions from the day before, you should have noted them down. They were clear on the day, and then there was a light shower the day before, but there was no big rain event. And then heavy rainfall in the last 2 weeks. Why is this here? It's because this is your little prompt. If you're doing this survey, planning a survey for some consultancy company, then you have to know that the trigger point is 3 times the median of the flow. And if it's higher than that, you have to stand down and you can't do any bugs or fish surveys. And then GPS coordinates. If you didn't take them on the day, go to Google Maps or Topo NZ Maps and look for those coordinates. And if you can't figure out, please let me know. We can do it together. Then question 2 asks you to calculate the total area fished. So first is the area that you were working on, so your survey site, and then there could have been area that you didn't fish or you did fish. So in the first reach, that was 15-meter length, and the average, well, the first reach, I remember we completely fished it all. There was no unfished area, but in the second one, we only fished 1 meter along the true right bank, and so there was more unfished area. So when you go through this formula on page 25 of the sampling protocol, so when you go to your Moodle on the fishing field trip section, there should be this protocol for electric fishing, for spotlighting and netting. It's by Mike Joy is the author. And when you download that, go through to page 25 and then find how you write that formula down here, and then the distances here. You had 15 meters for first reach, 15 meters for second reach. I want you to add both of those, and remember that 1 meter along true right was only fished in the second reach, while it was completely fished in the first reach. So add them both by using the formula on both, and then remember you have to add units. So you could write it separately, formula for the first, formula for the second, add it down, and then give me that answer. Use these. So wetted width average was 3 meters on the first one, wetted width average was 5 meters on the second reach, and that there was no unfished area in the first reach, and that only 1 meter along the bank of true right second reach was fished and rest was unfished. So 4 meter into 15 was unfished. So I want you to add them both, and that will be your answer. Then question 3, complete the following table for all the fish caught. So I hope you have your readings. If not, share them around, and if not, then let me know, because I have a little copy of our results, and then you can use that. So a common name for the fish, we didn't find smell, and for this question only use because when we were together we did results only for the first group of students who did it. So the results are for 15 meters by 3 meters. It's only for 45 meters square reach. And the second group, we didn't keep those fish, but we did find smelt in there. So I've added smelt in the table, and you can write it's caught outside of the sample reach. And then there were shrimp as well. That was more than 100. So there are other fish in there that you had found, observed, and then I want you to write their scientific names and then what their total counts were, and then relative abundance. So relative abundance you can find because you have data for 45 meters square, and then you use unitary method to calculate how many fish you would have for 100 meters square. And that's just you divide the total count by 45 meters square and then multiply it by 100 meters square, and you should get an answer for each and write that down. So that should be your table completed. Let me know if you have any issues with scientific name. Remember, I want correct format for the nomenclature, and that should give you the right table. Let me know if you have any issues finishing it. Don't leave anything unanswered. I don't like it when you have doubts and you haven't questioned them, so ask as much as you can. Then question 4, 5, and 6, the species that you caught, detail diagnostic features used to identify the organism. So I want at least 2 for each, list them all the 6, or how many ever we had done in the table, and then at least 2 or more if it needs more to be fully identified. Then and you can use NIWA's website or Landcare Research website for finding these species IDs, or you could use the ID guide I gave you. Any of those two should be helpful for you. Then also our lecture notes has very good resource. Then the overall species diversity, that's just the total number of species you found, different species you found, and you can count that and put that down. Then discuss whether the results that you found in 4 and 5, you have to discuss what fish were there, were they expected or not expected, and why. So I want you to explain the location you were in. I want you to understand what habitat was available, and then the surrounding catchment if that would affect. So location-wise, I want you to discuss whether it was close to the ocean, far from the ocean, did it have high altitude, low altitude, would you expect poor swimmers, would you expect good swimmers, or both, and what are these species that you would expect. Don't look at your results now, just what you'd expect. Then habitat availability, were there riffles, were there pools, were there vegetation, was there hanging vegetation, was there wooden debris, was there large boulders to hide under, were there banks, undercut banks, or backwaters that you observed that could have been good habitat. If there was this present, would you have high diversity, low diversity? Would you expect different buoys or just one? Would you expect inanga and eels? So what would you expect? You let me know. Then what was the surrounding catchment land use? So look through the map and then you can find those, let them know. What catchment will tell you is if there's high nutrient loads coming in. If high nutrient loads are coming in, was there lots of algae? If there's lots of algae, there's a stark shift in oxygen levels, which fish do not appreciate. So that would affect diversity or abundance of fish. So what would you expect in what you saw? Then discuss. As soon as it says discuss, I expect you to look up because I specifically chose this site as an NRC site, so you will have data to compare with. So I want you to look up old or current fish survey reports and then find the site and then compare the results that you did get with those reports, and maybe you find that your results have fish species that weren't in that report or vice versa, and then explain and discuss that. So take your time, discuss properly. I think this is a 4-marker question, number 6. So explain each aspect and then explain why you expected it, why it wasn't there, or why you didn't expect it and it was. So take your time and explain properly. Then, just